Hello everyone, this is Chris from Visual Components, and today we're going to have a look at the KUKA linear units and the KUKA positioner with the KUKA.Sim add-on. So first we're going to check if the add-on is activated. In this case we go to the File tab, Options, Add-on, and here look at the KUKA Sim add-on, and it should be enabled, so you might have the button disabled. We're not going to click this right now, but just go to the general options, and here I will select the controller version 8.6.9. You can change it to your controller version that you're using on your real robot or on your shop floor, depending here if it's a KRC4 or a KRC5 controller. I'm just going to stick with that for the moment and press OK. Now, in the e-catalog, we will add some needed components. For example, a KUKA robot. So we're going to go to the KUKA folder. Here we go. And I'm just going to take a high payload robot, for example, a Quantec of the second generation. And here I'm going to select my KR120, so with a payload of 120 kilograms and a reach of 2,700 millimeters. If I double click on that, it will generate in the origin of my simulation world. Also add my controller. In this case, it's a KRC4 controller. What do I need else? At the moment, I need a robot positioner. So in this case, a linear unit, and I'm going to go for a KL4000. So a KUKA linear unit with a payload of 4 tons. And if I double click on that one too, it will also generate in the origin of my simulation. Then, if I go to the manipulation mode PNP, plug and play, and select my robot, I can attach it to the linear unit. You might see this green arrow. So if I get closer to that green arrow, it will automatically jump in place and now is attached to my linear unit. So if I go to the manipulation mode interact, I can move around the robot here along my linear unit. And I could also move around my robot. I will reset the simulation because now we want to go for some settings of the linear unit. This is also crucial that you do this in the beginning of your setup and do not move the robot around here on the linear track. Do not use this movement options to actually turn your robot or to move it up and down. I will go back. So if I go here to my undo button, I will click 2 times undo. I will need to do this configuration with the options of my linear unit. Otherwise, it won't be written in the machine data. So to check that, I will first print the current machine data with this original setup. So I will click on this button in the component properties of the KL4000. And I can see the numbers of my kinematic chain. And here I see that actually it's 689 millimeters in Z position higher than the origin of the linear unit, and also here turned by 90 degrees. And I can see that this is then, there's another turn in my ET1 TFLA3 statement here. So I have another turn of the calculation of the kinematic chain. Now I can do this settings. So for example, I will start here in the component properties with the pedestal, which is kind of my booster frame, and I will select here a booster frame of 400 millimeters. And it will add it to my robot automatically. So now I have this metal booster frame here. In addition to that, we have the robot type. So it's a Quantec 2. This is also correct. And I will now also change my rated travel, which is currently at 6,400 millimeters or 6 meters and 40 centimeters. And I will change it, for instance, to 8 meters and 40 centimeters. This might take a moment, so don't be nervous if it doesn't happen in a second, because there's quite some calculation being made in the background to actually adapt this machine data configuration of the robot. But once this is done, you can see that now my linear track is longer than the previous one from exactly 2 meters longer, and I also have this rated travel of 8,400 millimeters written down here. Then we come to the robot alignment. At the moment it's 0, but I can, in this drop-down menu, I can select a predefined value, and this is kind of in the counter orientation of the clock, so counterclockwise it will turn, and if I select 315 degrees, you will see that the robot jumps into place and is now turned by 315 millimeters around my z-axis, and I can continue now with some more settings. For example, I can choose if I want to have my energy supply on the left side or on the right side of the track. By that, I just click here on this mirrored option. But I want to leave it on the left side of my linear track, so I'm just going to deselect it again. And I can also select if it's on the side or in the center. So now it's in the center of my linear track. I'm just going to go back because I have another option here. I can select a little wider energy supply. And now let's have another look at our machine.dat robot alignment statement. And we'll click on that button again and now make the output a little bit bigger so that we can compare it. And here you can see that the Z value changed from 689 millimeters to 1089, so exactly the plus 400 millimeter of our booster frame. In addition to that, the value in the ET1 TFLA3 changed from 0 here in this kinematic change to our 315 degrees. So we can see that it took over the settings that we made and that we can now start programming with the robot controller simulator, so the RCS. So this is what we will do right now. We will go to the Program tab and select our robot. And again, you will see here the program view, the different programs that we have. Currently, we only have the main program. If I right-click here on the program, I can go to my extended program view. I will make the window a little bit wider, because we can now again go on the machine data and double-click here on the machine.dat configuration. And we can go now also to our ET1. So if I press Ctrl F for search here in this window and look for ET1, it will directly take me to the settings of my kinematic chain here on the lower side. And at the moment nothing is written in because I haven't created the machine data yet. So I will reset the simulation and press play. Now you can already see that it changed the ET1 name to my KL4000. And here also the values that I saw before in my machine, in this robot alignment button, you can see the same values here. So regarding that settings, they are now also written in the machine data of the robot. Great. I will now go back to the program view of my main program. So we'll here click on right-click Show and go back to the program view. And now we have two home positions that are currently set here in the Canon position of my robot. Great. With that, I will now continue to program with my jog. So if I go to jog, at the moment I have the base null selected as on my home position. So if I jog the robot around, the robot will stay in its position. If I select a base, for example a base data 1, and move the robot around, you will see that the flange is staying at exactly the same position, just the robot in the background is moving, but the flange is staying the same. In addition to that, you just saw if I go over the limits of my linear unit, it will not stop. So at the moment I can see that my E1 value here on the joints is getting red, but I can still kind of go over the limits. So if I reset my simulation really quick and select this box stop at limits and go back to this interaction mode, it will automatically stop at the end of my linear track, which is kind of useful. So now I will program my first points. Maybe I want to go to this point and change a little bit the position of the flange, something like that. Create a first PTP movement. Then I will stay the same in my position, so I just will select a base null and move the KL a little bit, create a linear movement to my point 2. And now I want to stretch the robot again, something like that. Stay in the same position, just stretch it a little bit more, and again make a linear movement like that. And if this is done, I can now reset my simulation and click on play. And the robot will do as in reality. It will move accordingly. There we go close to a singularity, so it breaks a little bit the robot, but goes back into the home position. And now we also see the cycle times. We can add a cycle time calculation movement if we go here to the miscellaneous drop-down menu and get to the timer. We will get the first timer here, and I would select a second timer after my home position again, timer number 1, and I will need to go to the statement properties and set it to off. So now we can again create a little see the program, and it will calculate us the overall cycle time, which is 7.4 seconds. And now that we've done this, you can actually enlarge your program with your linear unit, and it will do exactly the same as on your real robot. Now, this was the first part with the linear unit. Make sure here to remember that you have to do all the settings over the component properties of the KL4000 or any other linear unit that you're using. Otherwise, this kinematic chain won't be calculated properly, and thus the robot won't work with the RCS module. Now, let's make it a little bit more complicated. If I go back to home, I will add another KUKA positioner. So again, in the KUKA folder, we have a KUKA workpiece positioner. And if I open that folder, I go to the DKP and select a DKP 400 version 2 and drag and drop it into my simulation. So this is my first external positioner, and I will have to connect it still to my robot. So I do that over this connect group and go to the interfaces. And now I will click on the robot workpiece positioner here and connect it to my DKP 400 and reset the simulation and deselect the interfaces. And now if I go back to my program view and click on my robot, I will not only have the slider and selection of the joint of my E1 that I can change here, but I will also have the DKP and the E1 of my DKP and E2 of my DKP. So this is the table that is turning right in here. So if I just select the slider and turn the table, it will follow as expected. Now, I can continue by also setting a base onto my DKP. So in this case, I will go to my base data 2, select here the options with the little gear. Now snap in this tools, snap and snap it onto the DKP table here. And select as a node, not the world coordinate, but the second link of the DKP. So if you select this little yellow option here button, pick property value from the 3D world, you can go to the DKP and select the second link, such as there is written DKP 400v2, double point, link 2. So now if I go to jog and move the table, you will see that the base number 2 is actually following. And with that, if I have my robot selected and select the base number 2 and turn the table, you will see that the robot follows in this current home position. So if I go to snap with the jog manipulation mode. Snap and go here, put the flange of my robot onto the DKP. And now turn the table. You will see it follows exactly this position. And I will now just create one point here and turn the table a little bit and twist it, something like that. So and create a second point here with also a PTP movement. And those two movements, I will include them before my home position. So I'll go on Control, select my 2 points, and now drag and drop them in front of my home position. Such as if I reset the program and run it, it will take into account my new DKP configuration machine data, do the programs that I programmed up front, and now go to my DKP and now turn. Well, there is a little collision. I could now improve that, but this is not the goal of this current video. I want to show you the limits of my external accesses with my KUKA robot. So I'm going to reset the simulation, go again to my home and to the e-catalog and add a second DKP 400 into my simulation on the middle of my linear track here. So the use case would be I have a first application here where the robot needs to do something on the DKP, and I have a second application on my second DKP. So I will again connect the second DKP with my KUKA robot here through the interface. And now it's calculating again a little bit, and you already saw that it changed the size of my controller. So now it's not anymore a little normal KRC4 controller, but it's an extended one, so a bigger one with more drivers inside. So I could go on and program a little bit, but I told you that I want to show you the limits. If I select another DKP, in this case maybe I want to have a third application on the right side of my linear unit, and I want to connect that also with my robot. So I'm just going to select here the little icon and connect it with the robot interface of my DKP. And now I will just press play. It will try to generate the machine data, but pop up an error telling me that there is more than 6 controlled external accesses per the controller or this device, and that this configuration is not valid. So I can actually check with this simulation if the application that I'm planning, it will work or will not work with my KUKA controller. And if I now deselect again here my disconnection by clicking on it and generate the machine data again, there will be no more error messages and the robot will work properly because my third DKP here is not connected anymore to this robot controller. Now you can export your project to WorkVisual. For that we're going to save it first. So I'm going to go to the File tab, Save As, go to My Models and Browse, and have already a project here, KL4000 and 2 DKPs. I will just leave it like that and say Save. I want to replace it, yes. And now I can export the project. I can see where I want to export it, but in this case I just click on Export. Right, and now if I go to WorkVisual with that project, I just opened this WorkVisual project and you can see the current configuration. And you can see that I have my KRC4 controller extended, my KL4000 linear unit where my robot is directly standing on. So this was the first part of our configuration. And we have the DKP, the first DKP 400, and we have the second DKP 400. And we have a third one, but this is not connected to our controller. So here also the KUKA.Sim add-on takes into account the objects that are in the simulation but are not currently connected. So this is also the message that I get here. And from here on, you could just continue with your normal commissioning process. So if you go to the files here and have a look at my KRC R1 program, I can see that it actually generated my main program with my home positions, with my several other positions that I'm going to. But in addition to that, I also have my system config.dat, where I have my different tool and base configuration. Okay, I didn't configure any tool, but I did configure a base. So let's see where this is. Here, this is my base configuration right there. And with that, I can now continue with my commissioning process in WorkVisual and then send it to my real robot. I hope this was useful, and I hope that you now can work with this external axes and linear units. See you in the next video. Thanks for watching. Bye.